We will now begin AGC Inc.'s Semiconductor-Related Business Briefing. My name is Nakagawa from the Corporate Communications and Investor Relations Division. I will serve you as a moderator today. I'd like to introduce you to today's speakers. Mr. Hideyuki Kurata, Representative Director, Executive Vice President. Mr. Nobuyuki Suzuki, Executive Vice President, President of Electronic Company. Mr. Tatsuo Momii, Senior Executive Officer, President of Chemicals Company. First, Mr. Kurata will present AGC Group's technology development strategy and semiconductor-related businesses. He will be followed by Mr. Suzuki, who will discuss the electronic semiconductor business, and then Mr. Momii will present the performance chemicals semiconductor business. After the presentations, we will move on to the question and answer session. We expect to conclude at approximately 5:45, and we appreciate cooperation. Mr. Kurata, the floor is yours.
My name is Kurata, CTO. Today, I'd like to explain our semiconductor-related business. We are engaged in a wide range of businesses as a material manufacturer. And recently, in particular, we have been seeing a significant increase in interest in our semiconductor-related products. I'd like to introduce how our company was founded and how our technology development has evolved, explaining why we have such a broad portfolio of semiconductor-related products, before handing over to the head of the Electronics Chemicals Company for more detailed explanation. Mitsubishi founding family member and the second son of Yanosuke Iwasaki, our founder Toshiya Iwasaki, took on challenge on domesticating the production of flat glass in Japan, despite the difficulties, and succeeded. Our spirit, the never take easy way out but confront difficulties, are still a corporate culture today. In addition, the founding aspiration of contributing to society through materials has been continuously passed down through the generations. This is directly reflected in our corporate philosophy: look beyond looking ahead and supporting people's lives around the world through our unique materials and solutions. Our industrial domains and product applications continue to grow and evolve even today. Since our founding in 1907, by continuously providing products needed in each era, our business has diversified from architectural glass to automobile glass and further into electronics, chemicals, and life sciences. We have consistently supplied products that meet the needs of the times, including glass for LCD displays, a wide range of functional chemical products, and materials and components for semiconductors. It can be said that AGC has opened up new markets through its unique capability to combine materials and solutions. Over a long history, we have built up composite technologies based on both inorganic and organic materials technologies, as well as design and processing technologies that enable higher functionality. In addition, our manufacturing capabilities, including stable production and design technologies for specialized products, have become major differentiation factors, including black box technologies. The ability to integrate and combine these strong core technologies is one of the AGC's greatest strengths and provides the foundation that enables us to offer a wide range of products in the semiconductor field. Since 2015, with a clear vision of what we aspire to be in 2030, we have clearly defined our core businesses and strategic businesses and have pursued growth through an ambidextrous management approach that balances us both. Through these medium to long-term initiatives, we are advancing both our contribution to a sustainable society and a commitment to continuous growth and evolution. We defined the 5 businesses that we have traditionally operated, which is architecture, automotive, display, essential chemicals, and ceramics, as our core businesses, and these businesses provide a strong and stable long-term earnings foundation. We have designated 4 areas: mobilities, electronics, life science, performance chemicals. As a strategic businesses, we have taken on bold challenges and drive the expansion of both revenue and profit. Through this strategy, we aim to transform our business portfolio into its optimal form and become a company that continuously creates a value. The semiconductor-related businesses we are introducing today fall within the areas of electronics and performance chemicals and are truly key drivers of our growth. By clearly identifying our sources of growth, we believe we can continue to accelerate the expansion of our growth areas in the years ahead. Looking at the performance trend of our strategic business, revenue has grown to approximately 2.4 times the 2017 level. In particular, focusing electronics and performance chemicals, which include our semiconductor-related businesses, we have achieved growth at CAGR of 8.9%. Although the growth in operating profit has been limited due to underperformance of life science, earnings from electronics and performance chemicals have expanded in line with revenue growth. Going forward, we will continue to position our strategic businesses as key growth drivers and further accelerate their expansion.
By promoting ambidextrous management, our priorities for R&D investment have been clearly defined. Using a matrix of market customers and organizational capabilities and technologies, we construct our R&D investment portfolio by combining existing and new initiatives. A comparison of 3-year aggregates shows investment in strategic businesses that exceeds 70%, demonstrating a strategy to accelerate the growth of strategic areas. That is how we have changed the allocation so that we'll be able to grow strategic areas. Regarding current and future technologies, we are striving to increase the probability of success by defining key technology fields and focus areas. We are paying particular attention to fields that will be next growth drivers, and among next-generation electronics, semiconductor-related materials is being a key focus area. As you know, in the semiconductor industry, while following Moore's law, the history of process node miniaturization has involved changes in lithography light source from I-line to KrF to ArF and ArF immersion, and now to EUV. AGC began producing synthetic quartz, a lens material for lithography equipment, in 1985. And in step with the evolution of semiconductors, we have provided core products that are essential to semiconductor manufacturing. And the core products are shown on this slide. Technology will continue to evolve in the future, and AGC will continuously work on the development of new products that will make us indispensable to the semiconductor industry in the future as well. We will contribute to the semiconductor industry without missing the right timing to enter the market. This first slide shows a product lineup divided into the front-end process for semiconductor wafer manufacturing and the back-end packaging process. We further categorize these into semiconductor process products and semiconductor manufacturing equipment products. Regarding our main products, I believe the heads of the relevant companies will explain them in detail later, so I will meet them here. Going forward, we will also focus on packaging materials, which is a growth area. From front-end to back-end processes and from process products to equipment products, we will offer proposals to our customers based on the breadth and depth of AGC's technology. Next is Mr. Suzuki, President of Electronics Company, to talk about AGC Semiconductor-Related businesses. Mr. Suzuki, please start your presentation. So this is Suzuki, President of the Electronics Company, and I will explain AGC Semiconductor-Related businesses. I will explain the key features of AGC's technology and development across the entire electronics sector. Our company is characterized by our ability to supply products that combine outstanding technologies in materials, processing, design, and evaluation. A unique aspect of our material is that we possess both inorganic and organic materials. In terms of processing, we possess a wide range of technologies, including not only simple glass cutting, but also polishing, high precision coating, patterning, as well as laser and molding. Furthermore, we do not merely manufacture products, but we also require expertise in composition design, optical design, and advanced simulation technology, as well as high-performance inspection, evaluation, and analysis skills. By combining these capabilities, we can provide unique solutions and have consistently brought cutting-edge and composite materials to the market. The same applies to our semiconductor products. For example, CMP slurries, we use organic and inorganic materials to supply cutting-edge, high-quality products. Through the synthesis of high-precision abrasive particle synthesis, dispersion processing technology, composition design, polishing, and evaluation using the same equipment as our customers. In the field of CPO, which is expected to expand in the future, we believe we can offer unique products by combining polymers and inorganic materials with processes such as photolithography, etching and laser processing, and integrating them with optical design and optical property evaluation. As explained earlier, using them, sustainable growth strategy in the semiconductor field based on the technologies described on this previous page will be explained. We have long focused our business development on materials for advanced semiconductors. As shown in the graph on the left, advanced semiconductors will continue to drive our business going forward. In particular, we hold a high market share in fields with high technical differentiation and expected long-term growth. Representative examples of existing products include blanks, CMP slurries, and components for semiconductor equipment. Going forward, we will also focus on the back-end packaging processes, which is expected to see significant growth, driven by AI and high-performance servers. Furthermore, the CCO technology acquired through M&A will become even more important. We have prepared a separate slide regarding the back-end process. For existing products, we will continue to increase the proportion of products for advanced semiconductors by leveraging the partnerships we have cultivated with leading companies and strengthening the development of next-generation products. Our new needs and requirements will continue to emerge in the back-end process, so development of the new product is essential. In the back-end process, we aim to establish our status as a provider of cutting-edge packaging solutions by offering new products and solutions to leading companies through our unique composite materials that combine organic and inorganic technologies. Additionally, since coordination with other materials and equipment is crucial in the back-end process, we aim to accelerate development through opening measures such as participation in Joint 3. In both front and back-end processes, we possess unique chemical products, and by conducting joint marketing, we aim to provide our customers with a broader range of solutions. Next, please. This slide explains the global presence. To strengthen our relationship with leading companies, we are enhancing local marketing efforts outside of Japan, US, Taiwan, South Korea, China, Europe, and Singapore. These are the areas that we have semiconductor-related marketing offices. In Taiwan, China, and United States, we operate these offices jointly with our chemical business, creating synergies. While development is centered in Japan, we also have development centers in Taiwan and in the U.S. In Japan, in addition to the Yokohama Technical Center, we conduct development at each manufacturing site, creating a system that enables effective product development, including basic research and prototyping. In Taiwan and other areas, we are conducting local marketing, so strengthening our partnerships with leading companies. Next, we will introduce our representative products. First is lens material for lithography equipment. Although this has not received much attention in the past, AGC holds a high market share in products for semiconductor equipment. And while EUV is attracting attention in semiconductors for AI and data centers, demand is also increasing for ARF, another advanced lithography technology, as well as KRF and I-line. AGC differentiates itself from competitors through the superior properties and quality of its synthetic quartz lens materials and holds a top market share for ARF lithography tools. Demand for synthetic quartz from customers is very strong, and we will continue to expand sales for KRF and I-line applications in addition to ARF. For semiconductor equipment, silicon carbide, which offers excellent heat resistance, is also one of our products with a high market share.
Next, I'd like to discuss EUV mask blanks. Since joining the EUV consortium in 2003, AGC has continuously advanced its research and development effort in this field. We are recognized by our customers as the only mask blank manufacturer capable of providing end-to-end production. As you know, the use of EUV lithography is expected to continue expanding, particularly for AI and high-performance server applications. While there are concerns last year that market might slow down, but increasing demand, including memory devices, along with comments from ASML, support our view that market will continue to grow steadily. With a higher utilization rate and improved lithography tool throughput, we expect the number of masks used per lithography to increase, which could further strengthen demand, and we are monitoring this trend closely. We achieved the sales of 40 billion in 2024, although sales temporarily declined last year. They have recovered this year, and we expect continued growth going forward. While leading manufacturers are currently in mass production at 2 nanometer node for logic devices and D1D generation for DRAM, AGC is already developing next and future generation technologies in preparation for further scaling. Shipment volumes for 2 nanometer class mass production are increasing, and we are also supporting products for PSM application in volume production. Evaluation for high-NA EUV applications are progressing steadily. Our manufacturing sites are located at AGC Electronics Motomiya and Kodiyama plant. We have continued to invest in line with the growing customer demand and intend to maintain an active investment strategy going forward. Next page, please. Next, I'd like to discuss CMP slurries, which are used in polishing processes for semiconductor manufacturing. Since mass production started in 2003, AGC has expanded its business by focusing specifically on serious slurries. We have maintained a leading position in serious slurries market for many years. Because slurries are used during semiconductor manufacturing, demand increases as semiconductor production capability expands, and the number of layers using serious slurry grows. Our slurries are used in high-quality demand applications such as STI layers. Because substitution is difficult, we expect demand to continue growing alongside semiconductor market expansion. One of AGC's key advantages is our fully integrated production system, spanning from raw material with abrasive product through the finished slurry product. This enables us to respond directly to customer requirements and provide high-quality slurries and provide carrier solutions. End-to-end production also provides advantages in many quality, both quality and consistent supply stability. As a new application area, we see promising opportunities in advanced packaging with 3D integration in back end. While silica slurries are currently the primary solution in this field, demand for cellular slurries are beginning to emerge. In addition, our chemicals business is developing cleaning agents used after slurry processing processes. By leveraging ACG's combined technology strengths, we aim to provide customers with comprehensive and integrated solutions. Next page, please. This slide introduces CCL, or copper clad laminates. CCL consists of glass cloth impregnated with resin and laminated between copper foils in both sides. The copper layers are patterned to form electrical circuit. CCL is used in a wide range of applications. The market is making particularly strong growth in AI-related applications. On the resin side, ACG has developed low-directed loss resins based on its chemical technologies, along with coating technologies and electrical performance evaluation capabilities built around these materials. So reducing dielectric loss depends on both the material used for glass cloth and lowering the dielectric loss of the resin impregnated into the both glass cloth. I think I need to speak up. So reducing dielectric loss depends on both the material used for glass cloth and lowering the dielectric loss of the resin impregnated in the glass cloth. Quartz is the material that offers lowest dielectric loss for glass cloth, but it is difficult to manufacture and also has a certain performance trade-off. By using AGC's low dielectric loss resin, higher performance can be achieved with the same glass cloth, or the required performance can be maintained even when using one lower grade glass cloth. Given the current tight supply-demand balance for glass cloth, our resin technology can also contribute to improved supply stability across the industry. We have already begun supplying prototypes for next generation 2 to 4 gigabps applications, and if these products are adopted, we expect a sales growth beginning next year. One of our new products in this field is RCC, resin-coated copper. RCC eliminates the glass cloth in CCL. As a result, it can be made thinner and smoother, and making multi-layer structure easier to manufacture. As communication speeds continue to increase, enhanced surface smoothness is expected to become a major advantage because it reduces signal degradation and improves signal integrity. Next page, please. Finally, I'd like to explain AGC's initiative in the semiconductor packaging field. This is a cross-section view of the advanced semiconductor package. Memory and logic chips are connected to the substrate through an interposer. At the bottom is the PCB, which provides a connection to the overall circuit system. To support higher speed data transmission, photonics-electronics convergence technologies are employed, enabling the integration of both electric and optical signals. AGC is deploying glass interposer for connecting semiconductor chips to substrate. For the substrate layer, we are developing glass core and build-up films. In particular, we are placing significant emphasis on the glass core technology because it is expected to play a critical role in larger packaging format chiplet architecture and lower power consumption, making a potentially large future market. For PCB applications, we are already supplying copper-clad laminations in mass production or also developing RCC. As a process material, we are currently mass producing and supplying glass carriers. In the field of photonics-electronic convergence, which support both electric and optical signal transmission, we are developing both MLAs, micro-lens arrays, and optical control and polymer and glass wave guides for signal transmission. The product I have discussed so far are handled within the electronics business. In addition, chemicals business is developing low dielectric other fields, low dielectric the fluoropolymer resins and silica fillers for various packages. We are supplying release films for process materials. As you can see, AGC has a broad portfolio in product covering multiple layers within the package structure. Furthermore, by leveraging expertise across individual layers, we aim to process optimized solutions that take advantage of adjacent layers. This concludes my presentation on AGC's electronic technologies, semiconductor business strategy, and key products. This concludes electronics segment of today's presentation. Thank you very much for your attention. Thank you very much, Ms. Suzuki-san. I'm sorry that the audio volume is a little bit low. If you still have problems, please let us know. So, Momi-san, please. Yes, I'm a Momi Chemicals President, and I'd like to talk about semiconductor-related business performance of chemicals. So this department is using fluorochemical exhibit multiple stereotypic simultaneously. We're providing the multiple the high functional the materials. I'd like to talk about semiconductor-related business growth strategy and 5 chemical main products. So this is about performance chemicals and fluorochemicals. We are using the brine electronics and using the bases and the fluorine and the natural gases are using that as a material to have a solid the business foundation. For the fluorochemical has a heat and also chemical resistance and very good electronic optical characteristics. And the material cannot be replaced by other materials. On the right-hand chart, for the semiconductor the equipment, we have the release film, pellicular raw materials, heat transfer food, packaging materials. For the very wide range of the processes, we provide the product. We have 4 strengths. First is the fluorochemical synthesis technology. Second, supply chain, using the strong and cost competitive supply chain starting from the brine electronics, electrolysis, and extended through in the in-house production. Number 3 is the resource procurement and recycling. Number 4 is group synergies within AGC Group. This is a strategy for our strategy field. We have 2 directions. One is the extending area where fluoropolymers and fluoroelastomers are used. The heat and also chemical resistant, which is differential technologies, and also we have performance chemicals. Mother plant, Chiba plant extended the capabilities to meet customers' demand. The second strength is the future business expansion areas, which is semiconductor process products. We have built and established the customer relationship, and we expand into semiconductor process materials and accelerate deployment into high-speed communication material market. For AI and semiconductor and for AI and data center, miniaturization and high-speed communications, we plan to meet customers' the emerging demand by a product. So our 2025 performance chemicals also 171.9 billion yen, and the 24% are the electronic applications, and that is almost the majority is our semiconductor business. And I'd like to talk about a detailed product and also the product we are currently developing. The first one is fluoropolymer and fluoroelastomer component for semiconductor manufacturing equipment, which is called Atlas FFKM. So for FFKM, the high-performance fluoroelastomer with a fully fluorinated structure in which all hydrogen atoms are replaced by fluorine, which is used as a sealing materials inside semiconductor manufacturing equipment, and which is very essential for sealing. What we pay attention to is a stable replacement demand, particularly for the etching processes. The harsh plasma environment requires replacement once every quarter. So the demand is stable in line with the semiconductor manufacturing. For the supply chain, we produce FFKM
and O-ring manufacturers make its sealing materials and supply to semiconductor equipment. So this is the supply chain structure. Our FFKM's strength is the industry-leading heat and plasma resistance. The environment is very harsh, but our product can be used with stability. And in terms of the environmental concerns, normally the emulsions and also the fluorine polymers are not used. We have the emulsion and the fluorosolvent free. We are leading company to do that. And we have two pillars for the future development. First, we will meet the semiconductor miniaturization advances so that we improve heat and plasma resistance. And second one is we recover discarded fluorine and recycling it at a circular fluorospar, achieving industry-leading recycling level so that we will become even more sustainable and as a differentiation. So we have a product to support different temperature. So less than 200 and also over 300 the temperature are target in the future. Next is about ETFE-based release film. AFLEX is my next topic. This product is used in the semiconductor back-end molding process, which is on the right-hand side. This is the consumables. IC tip is filled with the resin. This is placed between two molds and resin. This is very important to have a release of the mold. At AGC, we have a #1 share in the world. So demand increases in relation with the semiconductor manufacturing. So I also use an HBM, which is a next generation semiconductor memory. In terms of the supply chain, equipment manufacturers are molding the resin. The manufacturers are recommending our resin.
So this ETFE-based release film, the AFLEX, it has its proprietary resin design and molding technology. And as you can see on the right, ETFE resin, it has a film strength and also excellent mold following capability and also release capability. These three are shown, and we have the de facto standard in the industry. And in addition, AGC is a #1 supplier of ETFE resin from the resin to the film. So we are the only company that can follow from that resin to the actual development and production. And the molding process is very difficult. So it's very difficult to change to competitors' products. So we can sustain high maintenance levels. So HBM, we are going to see endurance and also new protections. So that is going to mean that the new lineup of these films will be offered going forward. Next, I want to talk about the pellicle raw material side top. So pellicle, as you can see on the right-hand side of the slide, in the photomask surface is protected using this pellicle. So photomask, they have foreign matters, and it protects it from having these being reflected. So it is very important from the quality control point of view. So foreign matters, it is not attached to the wafer, so we will be able to avoid any defects. So AGC has this side top, and it is offered for this pellicle material. So when it comes to the market going forward, because of the expansion of the semiconductor production sites and photomask demand increases, we believe that this is going to bring very strong growth going forward. The strength of this site is that the ARF and KRF pellicle raw material, there are virtually no substitute for them. So we have established a very strong position. The three differentiation factors. One is that because it is capable for thin film coating as it is a solution-based, and number two, it is amorphous structure and it provides high transparency and it delivers different properties simultaneously such as electrical insulation, water and oil repellency, UV transmitters and chemical resistance. And in the laser chart on the right, with the pellicles, what is very important is the UV durability and UV transmittance in both site compared to competitor products that shows superiority. So it cannot be replaced, and that is why we have a strong position in the market. Number 4, this is under development. This is thermal medium from semiconductor. It is called Amolia AF164. So during the semiconductor manufacturing, of course, when it comes to precise temperature control is needed for semiconductor manufacturing processes like deposition, etching, and ion implantation. And of course, the temperature control is going to be very important for the yield, etc. So precise temperature control is needed. And of course, this is a 30 billion market. And for AI server, it's leading, and it is showing a growth rate of more than 10%. AGC is working on the mid-temperature range. The existing competitors is focusing high temperature range and low temperature range. So mid-temperature range is a core market that we are targeting, and that is a position that we have established. So AF164 has 3 strengths. Number 1, it has 164 degrees, so it can be used in many different temperature ranges. For customers, they do not have to use any multiple temperature devices. Therefore, the total cost can be reduced, and also the equipment operation and procurement burdens are low. And it's a small environmental impact with low GWP is another strength. So when we look at the robust environmental control going forward, I think this is going to be a big advantage. And AF164, we are using and producing this domestically in Japan from upstream raw materials. So it has low geopolitical risk. As you can see on the right, the temperature range, it can be used environmental consideration and geopolitical risk. All these 3 aspects are covered very highly with AF164. So we like to utilize the relationship we have with our partners so that we'll be able to penetrate into the market further. And this is our last product. This is under development. This is post-CMP cleaner. And CMP, as Suzuki from electrics company mentioned, this is for polishing. And in the processes, this is very important for removing microparticles. And of course, there are some microparticles and chemical residues remaining on the wafer surface. And it's very important to have this removed. And I'd like you to focus within AGC, we have a synergy to be able to provide this product. So electronics company provides the CMP and the chemical company provides this solution. So this is a total solution that we can offer as a company. So CMP process is expanding, and we believe that we will see strong growth in the demand for solutions going forward. So the strength of this post-CMP cleaner is that we are focusing on the entire process, leveraging its know-how and accumulated technology specialized in Syria-based CMP slurry. And the CMP post-process, it shows a very high performance for removing these particles. So we were able to design this because we have a very good know-how of this CMP3, which makes this possible. Taiwan, in one area, we have created a technical center. We are able to grasp the needs of the customer, and we are able to provide a proposition of the products, and we'll be able to develop these new products. So, we would like to target the demand for leading-edge nodes and advanced packaging going forward, and we like to see stable growth centered on high-value, eco-friendly products going forward. So that was from the Performance Chemicals Semiconductor-Related Business Explanation. Thank you very much for your attention. Thank you very much, Mr. Kurata, Mr. Suzuki, and Mr. Amomi. Now, we'd like to ask Mr. Kurata to give us the summary. So, in summary, AGC aims to double revenues in its semiconductor-related businesses by 2030 compared to 2025. And we plan to achieve this through continued growth of existing high market share products and the launch of new products, including packaging materials. There are three key drivers of this growth. Number one, a strong demand for existing products, the EUV mask blanks, lens materials for lithography, and CMP slurries and release films. Among others, we ensure a strong market position and stable earnings through these products. Number two, expansion of the product portfolio. By focusing on materials for back-end packaging processes, we will broaden our revenue structure, which is currently centered on front-end processes, and strengthen our ability to propose solutions spanning the entire supply chain from upstream to downstream. Number three, group-wide technology and supply chain. AGC's ability to provide integrated solutions from materials to components and processes through the synergy between electronics and performance chemicals is a key differentiator. So based on these factors, we aim to achieve sustainable revenue growth by steadily executing investment plans in growth areas, leveraging our portfolio of products and technologies with clear competitive advantages. With that, we'd like to end our presentation. Thank you very much for your attention. Thank you very much. I'm sorry, that was a very important slide at the very end. Now, we'd like to start the Q&A session. If you have a question, please press the Q&A button and enter your question. It will only be accepted in Japanese, but if you'd like to use your voice to ask your question, please press raise my hand button, and we will appoint you. And when you're appointed, please turn on your microphone, and if possible, state your affiliation and your name and ask your question. Thank you very much. Now we'd like to start the Q&A.
Matsuda-san, please. Yes, my name is Matsuda, Mizuho Security. Can you hear me? Yes, we can hear you. I have two simple questions. The first question, this is a very elementary question. I just want to make a confirmation. So page 37, the last slide, I'm looking at that. And particularly this in pink, electronics, the semiconductor-related product in electronics, it's approximately 100 billion. So I think pink is about the 70 to 80 billion. So lens from to CCL, you talked about 4 products. For each, would you please give us the breakdown out of 70 to 80 billion yen? It doesn't have to be exact. I just want to have an image. That's my first question. And also this pink still, How about the profitabilities? So for the electrical company, there's a display and also electronic materials component. So out of components, I think the semiconductor opt is there. So how about the breakdown or the ratio of each product? And for the semiconductor-related business one, electronics, what would be would you please give us a certain image about the profitabilities? Thank you very much for your question. Okay, so both are electronics questions, so Suzuki-san, please. Yes, thank you for your question. The first question. Currently, actually, I'm not able to talk about details, like a detailed breakdown. However, the largest cells is blanks. Next, second is CMP slurry and CCL businesses following the blanks. And then after that is semiconductor lithography lens. So that is the order in terms of the size. So the second question about the profit. We are developing a lot of products, but for the semiconductor-related business and also electronics, we don't give the specific breakdown. But the electronic component, out of that, opt and the semiconductor for both sales and profit, it's 50-50. However, in the future, we would like to grow semiconductor-related businesses. So in terms of business size, we think that the semiconductor-related business size will grow in the future.
Next is on CCL. Of course, from material to the very end, I just want to ask you about the sensors that you have for these materials. When it comes to resin, you have talked about the PTFE, and also you have hydrocarbon that you're working on at the moment. So TTFE and hydrocarbons, including all these two, what are the areas that you want to target in the data centers? What are the CCLs? Have they been adopted already, or are you still working on the sample work? So what is your future direction in these areas? Thank you. So this was a question on CCL, so I'd like to ask Suzuki-san to answer this question. So I'd like to explain about CCL. As you mentioned, we have a strong characteristic with the resins. When it comes to chemical development, we are leading. Therefore, with resin, we are using two companies to develop. And this is a unique position when it comes to CCL makers. And of course, we are working on new products with dielectric properties. And in AI, for example, routers and switch, these are the areas that we are offering and being adopted. So 224 gigabps, the resin dielectric property is going to be very important. So using this new resin, we are trying to increase our sales, and we are providing samples. And from next year going forward, we believe it will be replaced by 224. So we believe that from next fiscal year, we will be making a contribution to our company's performance. So there will be some dielectric properties that are going to be the focus going forward. So that will be our focus going forward. Thank you very much.
Thank you very much. We'll move on to the next question. Kono-san from Nomura Securities. I am Kono of Nomura Securities. Thank you very much for taking my question. So by 2030, you would like to double the sales. So you have to increase the sales by 100 billion in 5 years. What products are the driver for sales increase in terms of the contribution or maybe size? That what product can increase the sales by how much? So we have a product for both electronics and performance chemicals. We'd like to ask Suzuki-san and Momii-san to answer your questions. Yes, from electronics. Yes, please. From electronics. So we think that in total, yes, the sales will be doubled, but for the electronics, this actually a back-end new product is not really included in this target. So actually, we expect the existing product to grow. For back-end, we do not know for sure what product we will have for the back-end, so we don't want to mislead you. However, having said that, as I touched upon earlier, blanks growth and CCL, we think these two are drivers, and as a polishing and lithography, these are really dependent on the equipment number of units, and they are increased. These products will grow for sure. So for the synthesized quotes and also the lithography, that's the second group to drive the sales. And Momii-san, would you please talk about the performance chemical? Yes, would you please show us the page 25 of the slide? Yes, for performance chemicals, as I explained today, the equipment, semiconductor manufacturing, the materials focusing, centering on the resin. There's the semiconductor process matching the materials. For the performance chemicals, yes, we'd like to double the sales also, but for the semiconductor manufacturing equipment products, we would like to make organic growth in this area. And for the semiconductor process products, we are developing the cleaner and also the heat resistant product. We would like to strengthen the performance chemicals business in this semiconductor process products. Thank you very much. Did we answer your question?
Thank you very much. I'd like to ask another question, if I may. I'm looking at page 22. The packaging-related solution, which is going to be a focus going forward. On page 22, there are many products shown here. In the next 5 years, which are the products that you expect the sales to grow? And when do you think those products will start to show sales contribution? Thank you very much. So I'd like to ask Suzuki-san to answer this question first, and Momii-san to add some comments. Yes, when it comes to semiconductor packaging, there are a number of products involved here. The market, which is expected to grow, is a glass core. The resin is used here at the moment. However, with larger packaging, because of large size packaging, if it's a resin, there will be some slides or it may be some heat-related issues. So glass is a focus right now to replace it. So glass core, if we are able to produce good product and provide as an industry, then there will be replacements, or for high functionality, we believe glass will be used more. So if it's going to get larger, I think it is going to be glass core. I think glass core is going to grow further. And when it comes to CCL, these are now provided as products. The AI servers that I mentioned earlier, the 224 Gbps, this is what is needed. And if CCL can enter that area, naturally, because this is already available, we believe that the growth will be quite large. And also, this is another area in which we are going to see this combination. And we believe that this is an area that we will be able to see the great enhancement for glass core and also in CCL. And also, when it comes to optical materials for photonic electron convergence, this is another area that we can expect growth coming from going forward. Thank you very much. Momi-san, would you like to add some comments? In performance chemicals, on the slide, the resin is what we are looking at. And this is all the electric resin raw material. And adoption is growing with different CCL manufacturers. And we believe with AI server market being grown, we will see supply to increase. And we believe that this low direct resin raw material combined with fluoropolymer resin is going to be very important going forward, especially for high-speed communications. And of course, the silica filler dielectric, this is something that we are preparing for mass production going forward, and this is going to be serving the needs for AI service going forward. Thank you very much. Anything else? Thank you very much.
Now, next question, please. Nishiyama-san from Citigroup Securities, please. Thank you very much for taking my question. My name is Nishiyama of Citigroup Securities. So page 21, please. Let's have a question about CCL. So one lower grade glass is being used. So is that a low decay second generation is used, but the first generation is possible? Or but maybe the second generation can replace the higher grade glass. And also, Nite or wave, you have the degraded PPE, but this is ELL series. Is it PTFE or hydrocarbon? Would you please talk about that? Yes. So this is for CCL. So Suzuki-san, would you please take this question? Yes. The first question is about glass cloth and resin relationship. Right now, especially what we are targeting at 224 area. So in that sense, the existing resin cloth is necessary to achieve high performance, required performance. But right now, 112 is NER. This type of a product can be used in combination. So the past existing resin needed cloth, but existing cloth can be used to reach the required performance. That's what we are aiming for. And for ELL, sorry about that. Okay. Maybe you can answer questions in later date after this briefing. Is that okay? Yes. I need to check my the document. So can we answer questions later? Okay. Okay. Can I ask you another question? For the second question, we will answer your second question through IR division. Can I ask you a different question?
Of course, go ahead. Thank you very much. As for EUV blacks, So CPU demand is going to get bigger. So from the major customers, demand, is it getting better from the beginning of the year? In 2024, the sales was over 40 billion, I believe. So do you think you'll be able to capture that kind of level when it comes to sales? And are you looking for mass production from customers other than your major customer in this area? So this is about EUV mask blanks. Susan, please. As for EUV mask blanks, I'd like to explain. I cannot give you details about different customer situation. However, comparing this year from last year, for each of the customers, the EUV, the blanks usage is increasing and it is stabilizing. And last year, one specific customer's demand lowered, but the usage by this customer is recovering this year. When it comes to the outlook, the current market situation and supply situation, we can expect a stable demand going forward. And when it comes to customers, for EUV mask blanks customers, there aren't many. However, for each of the customers, the usage of our product is increasing. So compared to 2024, looking at the customer portfolio, we believe that stable growth can be expected. That is a change that we're seeing in the trend. Therefore, last year was the bottom, and this year we are seeing recovery. And after 2024 and the demand in 2024, how can I say this? In that term, we believe that we will exceed it this year, and next year we will exceed the number further. Thank you very much.
Now we'd like to take the next question. Maeda-san, SMBC Nikko Securities, please. Thank you very much for taking my question. My name is Maeda of SMBC Nikko. I have two questions. The first question is about page 25, about performance chemicals, semiconductor-related, but it could be electronics application. For each product, would you please give us the sales breakdown? I'd like to understand the ratio against the sales, about the contribution to the profit. Which product has the largest, particularly significant contribution? Okay, that is performance chemicals, the contribution to sales and profit. Momii-san is going to explain. Thank you very much for your question. To answer to your question about the detail, the sales volume, sales numbers, about the breakdowns, I'm not able to disclose that information. But in terms of contribution for sales and the profit, which products are drivers, so the areas that will grow, for example, for the semiconductor manufacturing equipment the product, currently still already that this product for that application has the good the OP margin. So actually also we'd like to launch the product for semiconductor process products, which is currently is doing well. Thank you. I have another question.
And GPU architecture for AI materials may be used in the backplane. I think that is something that we are hearing. So do you see this as a business opportunity going forward? And of course, when it comes to fluoride, the control risk, regulation risk, is there anything that we need to be concerned about in this area? As first for the PFAS control, as you mentioned, the PFAS regulation, currently, the direct impact on our business and product, we believe, is limited. However, as you know, in Europe, this discussion is ongoing. Therefore, in the performance chemicals business, we do believe this is a significant risk that we need to recognize. But we believe that 5G and 6G, the communication related usage and also the semiconductor-related products that we talked about, these are essential for creating semiconductors. So we would like to continue to supply the products, and we need to reduce the environmental burden from production processes. And of course, we need to sophisticate how we control CO2. And of course, we need to look at replacement and alternative technologies as well. And of course, we are looking at electric properties. So we believe that this is another perspective that we can work on when it comes to fluorine products. But this is something that we are working on in development as well. So in your development processes, what is your positioning of your company in the developmental field? Well, in that sense, our company, from that dielectric property, we do have that material that we can offer, but we believe that the demand is going to be higher going forward, and it is not as if we are leading or we are delayed. So I don't think we are able to do that kind of assessment yet. Thank you very much.
Thank you very much. Next question. Yes. Chiba-san from BOV Security. Thank you. I'm Chiba, BOV Security. Can you hear me? Yes, we can hear you. Yes, I have two questions. Page 22, please. So out of this, glass core and glass interposer. Yes, these are my questions. So TGV glass core is actually sample. Chiba-san, I'm sorry, but we are not able to hear you well. Would you please repeat? Meiji, would you please speak into the microphone? Can you hear me better? Chiba-san, are you? Yes. Is this better? Yes, please. Thank you. Okay, so on page 22, there's a glass core, there's a TGV, the substrate sample shipment has started. So at AGC, there's a rumor that it's going to be behind, maybe later than 2030. So when do you think you can have the production? So if you have any outlook for the glass core TGV. So the TGV substrate, when you start the production, what is our plan or forecast? So example, please. Yes, for this is the TGV glass core, but it's a substrate. I think when we can start the production shipment, there's a technical matters not only with us but for the industry. The first target, original target was 2028, but I have a personal feeling. I think it will be sometime around 2029. That is the start of production. So our customers are not going to start using in a large scale, but they'll start using gradually from 2029. Then when glass core supply becomes a good in size, then I think we'll see the ramp up of the production cells. So to answer to your question, the timing is about 2029. Thank you.
Yes, thank you very much. Understood very well. May I ask one more question, please? So this is also on page 22 about dielectric products. And I don't think this is included in the double revenue by 2030. But when do you think it will come to make a contribution? Thank you very much. Thank you very much. Suzuki-san, would you like to answer this question? Yes, thank you very much. Maybe Maeda-san will be able to answer this question. So, Mr. Maeda, would you like to answer this question? My name is Maeda from electronics company. About the optical materials for photonic and electronic convergence, the NVIDIA switch has been launched, and that is where we have started adoption. And we make proposals now. And as Suzuki-san mentioned earlier, a micro lens array, MLA, this is optical, this is using parallelity so that it can be used for grading. And that is a kind of product in which we are getting a lot of inquiries about. And also, going into the future, there will be modulation going forward, and that is something that we can work on. And as was mentioned earlier, of course, the copper power related products, we have lots of inquiries, and we are providing samples at the moment. So as for the scale of revenue going forward, we are not able to give specific values. It will depend on how much we'll be able to expand the value chain. Therefore, we can give you anything specific, but it could be a multi-billion-dollar level of a business scale that we would like to target as we continue with the development. Thank you very much. So it will be a few billions of yens of market. So we'd like to take a part of that market. So this market is going to grow, and in FY28 or FY29, we hope that it can be started, and that is the kind of inquiries that we are receiving. So we hope that photonic electronic convergence will start to grow after 2030. And my follow-up question is, you said that adoption has already started. In other words, you mean that your products of your company has been adopted already? What did you mean by adoption by your customers? Well, our current situation is that development and also trials is now being done. So when it comes to mass production, that has not started yet. Okay, understood. Thank you very much. Thank you. That is all from myself. Thank you.
Thank you very much. You have several minutes. So I'd like to move on to the next question. Hirakawa-san of Daiwa Security, please. Yes, I'm Hirakawa of Daiwa Security. Thank you very much for taking my question. I have one question. So I have a question about the entire flow, actually. So you talked about AI. So low dielectric glass, like a CCL, is getting attention. But when we have a glass core, what do you think about will happen to CCL? Do you think that will be replaced by glass core? And you have the fluor resin. And what would be the chemistry or affinity with the glass core? So I have what the glass core is going to impact CCL or the fluor resin? And what will be the timeline that this product is going to grow? And again, if you have any evidence that this new product is going to replace the old products. That's my question. Thank you. About the package material. So first, I think Suzuki-san can answer your question, and then Momii-san can respond to the question about fluorochemical. Yes. About packaging, glass core and CCL PCB relationship. Glass core, once that would be penetrated in the future, the PCB, meaning CCL's demand, will not be replaced. It's not going to be converged. The glass core is for the resin for the substrate is going to be glass core. So PCB will stay. Therefore, cannibalization that doesn't happen to us. And then, for the future,
maybe the photonic electronic convergence and also substrate could be integrated, but that will be a positive business opportunity. So again, it's not a cannibalization. So about the fluorine. Well, for each layers, so we later offer how to make everything high functional, but if any of the product is going to be integrated into the new product to cause cannibalization, we don't think that will happen.
In performance chemicals, when it comes to this the dielectric, it is not used independently, so it will be used in combination with other materials. And as Suzuki mentioned, there would not be any cannibalization with glass core, so it will be case by case. It will be in combination with different materials that customers are considering its use. So in that manner, I think they will be used as products going forward. So today in the market, your fluorines are focus of the market. Therefore, here, glass cores and also there will be some good compatibility with the copper. Therefore, we believe that fluorine would continue to grow. Is that a possibility that you think? Yes, that is our understanding as well. Thank you very much. Thank you very much. It is time, so with that, we'd like to end the Q&A session. If you have questions, the IR person in charge will answer your questions going forward. So if you close the Zoom screen, there will be an IR survey. So we ask your cooperation in answering that survey for betterment of IR activity going forward. With that, we'd like to end the explanation session of semiconductor-related business. Thank you very much for your participation.